Hello and welcome to Awesome Astronomy on YouTube. Now, a few weeks ago, NASA launched one of the most important missions ever, and it mostly went under the radar because there are no people on board, and it wasn't one of NASA's really expensive missions that they, kind of have to shout about. But you need to know about it because it could save your life. In fact, it could save everybody's life. Because if you think coronavirus and the 5 million unfortunate souls that have lost their lives in the pandemic so far is bad, try losing 3/4 of all the plant and animal species on Earth. Every one of the 8 billion people and every animal on the planet that weighs more than 25 kilos. So stick around, because in this show we're going to show you how NASA may be about to show us how they can prevent one of the very few ways all of humanity could go extinct. Very few people noticed that on the 24th of November 2021, NASA launched a spacecraft on a SpaceX Falcon 9 rocket. At $330 million, the Double Asteroid Redirection Test, or DART, is one of NASA's cheapest missions, but as it's attempting to nudge an asteroid's course, it could be the mission that lets humanity know if we still need to worry about asteroid impacts anymore. And just because we've not had a direct hit from a big asteroid for a while, it doesn't mean we shouldn't worry about it. We should. It's just a matter of time until an asteroid vaporizes a city or wipes out entire species and sends us back into the Dark Ages, if enough humans actually survive. Because it's just a matter of time. Now, it could happen in 100 years or it could be 100 million years, but history and astronomy tell us it is going to happen. Think how confident we were a couple of years ago that viruses weren't too dangerous anymore. All because it had been 100 years since the last major pandemic, and science and medicine have advanced so much in the last 100 years. And here we are with 5 million extra deaths despite ventilators and the wonders of mRNA vaccine research. Now, for a bit of background on those asteroids that we're sure don't pose a threat to us, there are over 820,000 known asteroids, mostly in safe and stable orbits in the asteroid belt between Mars and Jupiter. But there are around 30,000 that stray closer, called near-Earth asteroids, or NEOs. Now, most NEOs just come close to us in their orbits, but aren't going to hit us. In fact, to calm any fears before we start getting all scaremongery, there are no objects that we've found that are going to hit Earth in the next 100 years. If you hear of any, they are almost certainly clickbait. Because we've got really good at finding near-Earth asteroids and calculating their paths, and only the larger and easier to spot asteroids are going to give us a really bad day. But every rocky body in the solar system is scarred with craters from asteroids and comets that show how often these big impacts are and how often they happen. Mercury is covered in impact craters. Venus has more than 900 craters caused by asteroids. Mars has 1,200, 200 more than Venus, but our closest neighbour, the Moon, has more than 1,600 impact craters. If there is such a thing as God or fate, they're screaming in our face that this shit is real. But Earth is quite unique in it having plate tectonics that rejuvenate the surface of our planet, removing evidence of ancient craters. And we have liquid water and vegetation that covers up a lot of the surface detail. But there are still countless craters showing how vulnerable we are to space rocks. The Red Fork crater in South Africa is the largest and oldest impact crater we know of. A 7-mile wide meteorite crashed and it blasted out a crater 150 miles wide. This would have killed all surface life on Earth and created mega tsunamis and a nuclear winter so severe that it triggered an ice age. 214 million years ago in Quebec, Canada, the 60-mile wide Manicouagan crater was formed by a 3-mile wide meteorite. Geologists have shown that craters of a similar age in Manitoba, North Dakota, France and Ukraine form a neat line suggesting that a much larger asteroid broke up in the atmosphere and deposited destructive chunks across half the globe. just like the Shoemaker-Levy 9 comet that we'll talk about hitting Jupiter in a moment. More recently, in Arizona, there's a 3/4 mile wide crater that you can visit near Flagstaff that was made by a meteor 50,000 years ago. The 10 megaton blast would have caused lethal burns to anything living within a 20-mile radius. In fact, the leading theory for how the moon came to be is that it was formed as material was blasted away from the Earth after a giant collision with an object the size of Mars. And we know that several of the larger meteorite impacts on Earth have caused mass extinction events, with the most famous one, of course, being the Chicxulub impact 66 million years ago, which wiped out the dinosaurs and most other animals and plant life. We could call that a lucky strike because our rodent ancestors were able to thrive and evolve ultimately into us without so many large predators around. But if another large asteroid had headed our way in the last 300,000 years that humans have been around, that would have made us extinct. And if you're wondering just how much of a risk asteroids are to us now, a meteor just 30 meters across is large enough to burn up in the atmosphere and create a 1 megaton shockwave that can smash windows and damage light buildings. This happens about every 180 years or so. Anything entering our atmosphere that's 100 meters across won't fully burn up and will hit the Earth with the force of 3,000 Hiroshima-sized bombs leaving a crater a kilometer across. More if it's an iron meteorite. It's calculated that an asteroid hits our atmosphere and burns up with the energy of 1 Hiroshima-sized bomb every year. But as most of the Earth is covered in ocean or unpopulated deserts and vegetation, they rarely hit dense towns and cities, fortunately. But we do still get warnings. Here in England, a fireball was seen on the 28th of February 2021, and fragments were found showing it to be a 4.6 billion year old meteorite originating from the asteroid belt. In Alabama, there was a fireball visible from 3 American states in 1954 as it streaked through the atmosphere, with witnesses describing hearing sonic booms. In this instance, though, the 3-kilo meteorite crashed through a farmhouse roof. It hit a cabinet, slowing it down further before hitting a sleeping Ann Hodges, the only person known to have been hit by a piece of falling space debris, and lived another 18 years. In 1908, Siberia witnessed an airburst from an inbound asteroid or comet 5 to 10 kilometers across above the Earth's surface. Luckily, instead of hitting the Earth, it probably came in at a very shallow angle that meant it burned up in the atmosphere, but still felled around 80 million trees over 830 square miles. And more recently, in 2013, a 17 to 20 meteor asteroid burned up in the atmosphere over Chelyabinsk in Russia. About 7,200 people were injured by broken window glass shattered by the shockwave. 3,000 buildings were damaged in 6 cities across the region by the explosion's shockwave, which caused over £30 million worth of damage, and that didn't even hit the ground. Paul went on BBC News to talk about this event and to show off his sartorial elegance. But the impact of large comet fragments on Jupiter in 1994 shows bombardments are still going on in the solar system. The Hubble Space Telescope was able to capture this in real time, and while Jupiter's immense gravity is often seen as vacuuming up space debris and keeping us safe, its gravitational appeal also pulls more debris into the inner solar system than we'd get if it wasn't there. So in the balance of things, Jupiter probably helps and harms us in equal measure. And all of this has made asteroids and comets a threat of such gargantuan consequences that it's plagued us for all of human history. Until now. The events of the next year may demonstrate that while runaway greenhouse effects that made Venus uninhabitable, nuclear war, or more virulent pandemics may still be the death of us all, asteroid impacts could be struck from that short list of global extinction risks. But I'll make it clear now that there are no dangerously large asteroids that we're aware of that are likely to hit Earth in the next 100 years. But DART will be the first demonstration of an impact technique designed to change the motion of an asteroid in space and thereby divert its path away from the Earth. So in the future, if we do see an asteroid or comet coming our way, the technology needed to protect us is already in development, and if successful next year, it'll already have been proven. And the target for this impact test is twin asteroids Didymos and Dimorphos. The two bodies that make up this binary pair are about 780 metres across for the larger body and 160 metres across for the Moonlet. And both objects would be catastrophic to life on Earth if either of them hit, but they won't. And this isn't a mission to divert the asteroids because we need to. It's a mission to test the technology on asteroids that come conveniently close rather than on a path to hit Earth. So the DART spacecraft will deliberately crash itself into the smaller Moonlet at a speed of approximately 6.6 kilometers a second, using an onboard camera and autonomous navigation software to hit the target. This will cause the Moonlet to change speed in its orbit around the main body by a fraction of 1%. But this tiny change will reduce the orbital period of the Moonlet by several minutes, enough to be observed and measured using telescopes on Earth. So, DART was launched on November the 24th, 2021 on a SpaceX Falcon 9 rocket from Vandenberg Space Force Base in California, and after a year of cruising, it'll intercept Didymos in late September 2022. At 11 million kilometers from the Earth, it'll allow ground-based telescopes and planetary radar to measure the change in the Moonlet's momentum and help us understand how useful this would be to deflect any future asteroids that look like they're headed our way. And if you're thinking, well, why not send Bruce Willis with his pockets filled with as many thermonuclear bombs as he can carry to blow the asteroid to bits? Think of it like this. Do you want to stick nuclear bombs on top of a rocket which is essentially a controlled bomb itself, and then just hope it doesn't explode in the atmosphere on the way up? Then sending astronauts up to place the bombs in convenient spots on the asteroid is so complex a suicide mission and requires a rocket that we don't have yet. We also don't want to split or fragment an asteroid because then it becomes less like being hit with a rifle bullet and more like being peppered with buckshot. And of course, Bruce Willis is no spring chicken anymore. And robotic spacecraft are already a fast-moving object that can impart their momentum into another object to move its course. If we hit them far enough out, just a change of a fraction of a degree is enough to knock it off course. So the important thing becomes good ground space surveillance to reduce the number of asteroids that we only spot as they zip by us. But as we showed in this video, if the dinosaurs had a space agency, they wouldn't have been wiped out, but we probably wouldn't be here either. So hey, swings and roundabouts.